Thank you, everyone. So, why I'm here today? Who knows? Let's start with something super easy. Who I am? I'm Mirko, and as my GitHub status says, from Monday to Friday, I'm full stack Pythonista. I do basically everything with Python, and on Saturday and Sundays, I'm a core Kivy developer. And as someone might have noticed, I'm from Monza, Italy. Yeah, where this happened. But trust me or not, I'm Max fan, and tomorrow I will be in Amsterdam, say Supermax doing qualifying. But we all here today for a reason, and this reason is that Python is just awesome. But what makes Python so awesome? Well, you, the community, and the ecosystem. And that's what happens when you ask an AI to generate a background image that represents Python and its ecosystem. Well, not so well done, AI. But, again, why I'm here today? I'm here today because Kivy is part of this ecosystem and is proudly community-driven. These are all our code contributors along our repositories and are so lovely. And we can't be Kivy without them. And we also have 195 sponsors and supporters on Open Collective, which is going to be super important for us in the future. But let's talk about some history. I guess we can consider this commit as the Kivy birthday, which is 13 years ago. Wow. But everything started from PyMT. PyMT, Python Multitouch, has been created in 2007, 16 years ago, by Mathieu, which is the creator of Kivy. And Kivy still shares chunks of code from PyMT. Kivy is made for today and tomorrow. Novel input methods such as multitouch have become increasingly important. We created Kivy from scratch specifically for this kind of interaction. Well, even if that statement has been added a quite a long time ago to our documentation, still look fresh, even if the most important things may have changed meanwhile. Okay, Mirko, Kivy looks like a robust and long-maintained project. But what is Kivy? No one said it to me. Well, Kivy is the open-source Python app development framework. With Kivy, you can build and distribute beautiful Python cross-platform grid apps with ease, and it's one of these applications. Why we should choose Kivy for app development, and how I can persuade myself or my coworkers to use a Pythonic way to develop applications. Well, Kivy is great for freelancers, small teams, and big corps. But why? Well, because Kivy is cross-platform. So you only have to write once, and then you can deploy anywhere. Where anywhere is iOS, Android, macOS, Linux, and Windows. That means less code to maintain. And also because Kivy is fast, because time-critical functionalities are implemented inside them, is GPU accelerated when it makes sense, and also implements intelligent algorithms to minimize cost operations. And also, for businesses, Kivy is business-friendly, because Kivy is released under MIT license and is 100% free to use, and is professionally developed, built, and maintained. Companies like the one I work for and individuals are using Kivy for their projects every day. But when I was writing the first version of these slides, and it was 2022 and it was in Rotterdam, I needed to explain to people that Kivy, the part of the ecosystem you use to create the UI is just one small part. So Kivy is just the visible part of the iceberg. So let's have a guided tour to the Kivy ecosystem, and this is here. Why Kivy is an ecosystem? And what refers to the Python ecosystem? Well, we have what I call being cross-platform, which is PyGenius, PyObjects, and Player. And then on the other side, we have the packaging part, which is Python 400, KVUS, and Bulldozer. Let's start with PyGenius. What is PyGenius? PyGenius is a Python model for assessing Java classes as Python classes using the Java native interface. That means you can access Android APIs and third-party Android libraries from Python. And you also access Java classes on your desktop environment. And this doesn't need to be in a Kivy application. You can use PyGenius also in your library, in your web application, or in your CLI application, when you want to integrate Python and Java. So let's take a look at the example. What I'm doing here, I'm just importing from with the autoclass helper from Pygenius, and then by using the autoclass helper, I'm getting access to the toast and string classes. And then by using the toast and string classes, I'm getting this result. I'm getting my hello from Python in my Android phone in just a few lines of code, and without no knowledge of Java, and without no X dependency. Unlike Pygenius, we have PyObjects. With PyObjects is a Python model for assessing Objective-C classes as Python classes using the Objective-C reflection. So again, if you need to access native and third-party APIs from macOS and iOS from Python, you can use PyObjects. And again, doesn't strictly need to be a key application. You can also use in your CLI or in your library. And the usage is pretty similar. What I'm just doing is to import the autoclass helper from PyObjects, and then by using the autoclass helper, I'm getting access to the NSRoute class. And again, in just a few lines of code, without no knowledge about Objective-C, I'm getting access to Objective-C classes. Then we have Plier. Plier is a platform-independent API to use features commonly found on mobile platforms from Python. What I'm doing here is just to import Plier, and then plier.tts, which is text-to-speak, .speak hello world. If I run the script on my Mac, it actually says hello world at loud voice without no extra setup needed, without no extra dependencies needed. And like TTS, you can access accelerometer, audio recording, barometer, battery, Bluetooth, brightness, and so on. And obviously leverages Pygenius and PyObjects where needed. So Plier is the Pythonic alternative to access platform-specific features. So we are now ready to deploy a fully featured app. Well, we still need to package it. And to package it, we have Python for Android and Kivy US. With both, you can create your own Python distribution along with the needed models and dependencies, and bundle it into an artifact that can run in your device. So these tools are just copying my dependencies and coding an artifact that can run on Android or iOS. Well, unfortunately, it's not that easy, at least for us. So let's have a quick whiteboard session. Why is not it easy to package a Python by app? Any clues? Fast. No clues?
Because it's difficult to get other dependencies into your project.
Let's go ahead. So we need to package a Python interpreter that's able to run on Android or iOS. We need to start this Python interpreter. Hey, come on. And non-plain Python packages are not available on PyP for Android or iOS. And on iOS, we are required to statically link everything in the main executable, at least right now, but we are changing that. So no dynamic libraries, loadable libraries inside your dependency. And node having is available on iOS or Android, like subprocess, for example. You can just use subprocess on iOS. Not now, not in 3 months, not in 1 year. Nope, is not supposed to run due to iOS limitations. And data scientists, how many are there? Oh, great. Love libraries based on Fortran. I don't know why, but cross-compiling Fortran is so painful. And no, Android doesn't have apt-get, and no, iOS doesn't have Brew. So you can just Brew install something inside your iOS device. So you need to cross-compile and package it into the application, and many, many more. So how we managed to fix it, and how the community is working on it. Well, let's use an example approach. We have an application with Python 3, which is our lovely Python interpreter, that needs to be cross-compiled and patched to run on the target platform. Same applies for its sub-dependencies, like OpenSSL, libFFI, and SQLite 3. A recipe will take care of it. Then we have libx264. x264 is a free software library for encoding video streams into the H.264 compression format. Need to be cross-compiled, and the recipe will take care of it. Then we have Kivy, which is a Python package, but have compiled components, which need to be cross-compiled, and also need a few compiled external dependencies like SDL2. A recipe will take care of it, and something similar happened for NumPy. So again, a recipe will take care of it. And then we have PyTZ and Babel, which are just plain Python packages, and we can just pip install them, yeah, with the proper CLI flags. So 90%, where 90% is a random number within 80 and 100% of complexity is in recipes. But what are recipes? Well, recipe are a set of instructions that simplify the patching and cross-compilation process for various types of packages. Oh, so complex. Yeah, but you don't need to worry about that, unless you want to submit a PR or add a new recipe. The set of the already available recipes are enough for the average job. And if they are not enough, you are probably doing something wrong. So the final result is your Android or iOS app with the Bootstrap, which starts basically having the Python 3 interpreter, which is being cross-compiled, then the Python packages, both cross-compiled and plain Python packages, then the libraries, cross-compiled, like OpenSSL, libffi, etc. And finally, your app, allowing your coding assets. And then we have Bulldozer. What is Bulldozer? But let's start by talking about the key points of Bulldozer. Your app, your rules, and one-stop packaging. Why? Because with one single Bulldozer.spec file in your app directory that describe your application requirements, you can create pages for Android, iOS, and macOS, and support for Linux and Windows is coming. So, let's take a look at the usage of Bulldozer. Bulldozer init. That means, hey, Bulldozer, can you please create a Bulldozer.spec file that can later edit it? Bulldozer, Android, debug, deploy, run. Hey, too much. It means, hey, Bulldozer, can you please build an Android artifact in debug mode, deploy it on the device, and run it. So one single line, and you have your application running on iOS. Then finally, let's talk about having a brief introduction to the visible part of the iceberg, Kivy. Kivy abstracts basic tasks such as opening a window, displaying images, displaying text, playing audio, and so on. This makes the API both easy to use and easy to extend. Most importantly, it allows us to use specific providers on the respective scenarios in which your app is being run. So, as an example, if I have a camera app, a cross-platform camera app, that needs to be run on my iOS device and on my Android device, Kivy chooses the best core provider for the camera to use. So, on iOS, I'm going to use the Wu Foundation camera, and on Android, I'm going to use the Android camera implementation. So you don't need to worry about that. Yeah, in certain situations, you may want to change the default, and you can still do that. Then we have Kivy the Kivy design language. The Kivy language allows the developer to create the widget tree in a declarative way, and to bind widget properties to each other or to callbacks in a natural manner. Yeah, you can still write Python code to create the widget tree, but please don't do that, as you may find out later is not quite straightforward. Kivy language is here for that. And with the Kivy language, it allows you to very fast prototype and easy changes to your UI. And most importantly, it allows separating the logic of your application from its user interface, which is super important for maintainability. Then we have properties. A lot of properties, like numeric property, string property, list property, object property. But what are these properties? Well, these properties implement the observer pattern. And to use them, you have to declare them at class level. So, Kivy properties help you to easily manipulate widgets defined in Kivy language. So, again, please use Kivy files. And automatically observe any changes and act accordingly. And also check and validate values and optimize memory management. But let's take a look at an example. We have the numeric property, which defaults to 0 and is named clickCount. And then we have a method, which is inClickCount, that every time it gets called, clickCount gets incremented by 1. And then we have onClickCount. What is onClickCount? Well, each property, by default, provides an underscore property name event. This is called whenever the property state value changes. So when clickCount gets changed, onClickCount gets automatically called, so you can observe changes and act accordingly in your code. Then we have clock. You may find yourself scheduling something, and we have clock for that. Clock is useful to schedule a function call in the future, once or repeatedly at specific intervals. So as an example, with schedule interval Michael back 0.5 means, hey, please call Michael back every 0.5 seconds. And you can obviously cancel it. Now, schedule once Michael back 5, it means, hey, please call Michael back in 5 seconds. Or schedule once Michael back, it means, hey, I need it ASAP, please call it, I need it. And it usually runs during the next frame. And then we have events. A widget has two default type events. One of them, we already seen it previously, but we have the widget defined event. As an example, for the button implementation, we have the released or pressed events and are sent via dispatch. So on release and on pressed are already available for the button implementation. And then we have, as we seen previously, the property event. So if a widget changes its position or size, which are also properties, an event is fired. And then we have canvas, because Kivy is a UI thing, right? And we need to display things on the screen. And to do that, we have the canvas. Each widget has a canvas, a place to do one. The canvas is a group of doing instructions that should be executed whenever there's a change to the widget graphical representation. And canvas before and canvas after groups can be used to separate instructions based on when you want them to be executed. And you can add instructions either from the Python code or from the Kivy file. So how we can do that? Well, let's start by using a blank box layout. And then with canvas before, so before everything, we are setting the color to red. And then with the color set to red, we are drawing a red rounded rectangle. Then on top of it, we are placing a label which says hi and which is full white. And on top of everything else, with canvas after, we are setting the color to blue but half the alpha value, and then we are doing an ellipse. So for doing that, we should use canvas before, setting a label, and then using canvas after. If you add canvas instructions from the Kivy file, so please again use the Kivy file, the advantage is the canvas is automatically updated. Whenever any Kivy property, they depend on changes. Self-pose and self-size are also Kivy properties. So if the size or position change, this one gets automatically redrawn. If you do that in Python, you need to do that by yourself. Then we have built-in UI components, like entry layout, box layout, flow layout, which are just for layouting things. Then we have an enormous amount of other kind of widgets, like accordion, action bar, bubble, button, camera, tree view, video, and so on. And if we do not have it, that's still our community model garden. Kivy Garden is full of flowers, and our flowers are Kivy widgets, add-ons, and related software. Some examples are ZBarCam, which is a real-time barcode and QR code scanner by using the camera. Or then we have MapView, which is a Kivy widget for displaying interactive maps. Or we have a Graph for graphing things. And then Kivy also gives you freedom. Why freedom? Because Kivy provides the bricks, our community garden full of flowers, but you can even do more. Because even if Kivy comes with its own set of icons and its UI theme, there's no need to stick on it. You can create new widgets and customize existing ones. These are two examples. One is an app that I maintain, which is a for smart home ecosystem. Obviously, Kivy doesn't have the rolling shutter widget, this one. And another app from one of our sponsors, which tracks the car on the racetrack in real time. Obviously, Kivy doesn't have the car widget with all the graphics data. And spoiler, at least for me, is easier to write some CSS3. So we previously seen how packaging and being cross-platform could be challenging. So it's tip and tricks time. Please follow this roadmap for a smooth cross-platform experience. And I'm not talking just about Kivy applications, but all the cross-platform things. Think, test, and choose. Think why, which dependencies I need. And I really need all these dependencies, or can I evolve some of that by just writing a 5 line of code instead of 1? And can I use plain Python alternatives to non-plain Python dependencies? Yeah, probably slower, but we don't need a recipe to build them. And can I take advantage by using a platform-specific implementation, faster, smaller upsize, test every dependency on every platform you want to support, now and in future. This is super important. And test platform-specific implementation, as they might not work as you expect. And if the test thing goes super smooth, why are you still here? Go ahead and implement your application. Otherwise, choose a recipe to build a non-plain Python dependency is not available. Are you comfortable to patch your your dependency and write a recipe? It's hard. I say that. And you're comfortable with it and you want to change, do that now. And now, do you remember this slide? And do you remember is working on it? What are these numbers? 730, 738. Any clue? PEP 738 Android as a supported platform, and PEP 730 adding iOS supported platform. And these are all accepted, and they are coming in Python 3.13. So finally, we are getting official support from Python in Python 3.13 for iOS and Android. What it means? It means less patching, less recipes, and more awareness by package maintainers about mobile platforms. So hopefully they don't make things harder for us. And now the future. We are announcing Kivy 3.0.0. And what to expect? What? We already started the cleanup phase. We did the removal of deprecated obsolete APIs. We hired a robot for that, no, just kidding. And most breaking changes will be transparent for the majority of developers. Then, we introduced Angle, AGL, and OpenGL Yes provider, mostly for Apple platforms, because Apple deprecated OpenGL and OpenGL Yes and want us to move to Metal as soon as possible. The good news is that Kivy apps using Angle with Metal as a begin renderer are even faster. And then we are also getting Skia as a graphic provider. Skia is a backend for a graphics provider for a lot of things, like Chromium. And we decided to choose Kivy, Skia for the next release of Kivy. And with Skia, we are going to have a new Skia canvas, which is an alternative implementation for our canvas, which uses Skia rendering, which can be faster in certain situations, and also Skia text paragraph, our new default text rendering engine for our label and text input. That means no more issues for RTL or no Latin languages, which are so painful to manage by ourselves. Phone fallback, like for emojis, for example, or many, many more. And we also going to have the latest support in Kivy via Skia, and likely also a new SVG renderer. And then an almost native text input. Yeah, because for quite a long time we relied on SDL, which is one of our major dependencies, provided solution for text input. But even if they come with no additional code cost, it doesn't cover all the needs. So in Kivy 3.0.0, with a brand new text input, we'll offer Nemo's native experience, like text replacing, CJK languages, and context-aware keyboard. This is a major change and required to break the API. Then we are getting a modern camera API, because over the past few years, the camera APIs on mobile OSs evolved quite a lot. In Kivy 3.0.0, we will allow developers to use all the features commonly found on mobile modern cameras APIs, multiple cameras, and ML recognition. And also accessibility features. Because in our vision, to make Kivy a solid platform to build up for everyone, introducing accessibility features and making Kivy apps accessible for everyone by default has become increasingly important. I have to thank the SSK developers, which are supporting us in the process and which also have a super nice library. And ITA, well, we are community driven and working on the project during spare time. So no real ITA here. But we are the best way to get it as soon as possible is to come and help with code, documentation, examples, marketing, and whatever you think it can make a difference. So, thank you. If you want to talk about Kivy, feel free to reach me later in real time and in real life. And if you want a Kivy t-shirt or a free Kivy sticker, both are free, I have with me, and me and KLM will be happy if you want some of them. Thank you.